Uh, so by the coverage we will know that, uh, and different type of coverage like toggle coverage, uh, path coverage,
Okay.
functional coverage, code coverage.
Okay. So in code coverage, we have path coverage, branch coverage, functional coverage, or how it is? What are the
Yes, yes. In
coverage
cross coverage,
we have?
in cross coverage we have path coverage and other coverage.
Okay. Can anyone say is he right, or is there anything that you guys want to add?
It's that in the code coverage we have few coverages, line coverage or statement, path coverage, toggle, FSM,
Okay.
branch coverage,
Okay.
and we have functional coverage.
Okay.
Then we have cross coverage.
Okay. So in what instance cross coverage will be useful? Basically, why do we need cross coverage?
So cross coverage is used between two or more cover points.
Okay.
When explicit bins are not defined in the coverage group,
Okay.
we can use cross coverage so that we can add them.
Oh, okay. So is it not something like when we have simultaneous actions has to be monitored, then we use cross coverage, right?
Yeah.
That is the main purpose of cross coverage. It's not that we don't have an explicit bins or something. It's like when you want to cover the multiple scenarios simultaneously, in that case, we use the cross coverage, because as your answer itself says that in cross coverage, we can do the cross of different cover points. So already individually, we are trying to cover those cover points. If I have a scenario where I want to monitor all the three cover points, for suppose, you have three cover points already declared, and you want to observe the all the three cover points simultaneously, if this work, how it will, or you have a condition like when select is high, the other two address and data should be definitely have some valid data. So you can write a cover point for valid data, one cover point. You can write for valid address, one cover point, and you can write one cover point for P select. And then you can cross these three, and you can mention in such a way that how they have to you will always provide the valid data cover point already. So you have to do the cross of all these three cover points. So you can simultaneously monitor the three cover points at once, and it will also give us more number of combinations. If you want to sit and write all those combinations, it will be very complex. So just by using cross, it will, for example, in one cover point you have 0 and 1, the other cover point you have 0, 1, 3. So using cross of that first cover point and second cover point, it will cover how many combinations here? Two combinations, 0, 0, 0, 1, 0, 3, like 1, 0, 1, 1, 1, 3. So totally 6 combinations are done just by writing a single word like cross. So this is the main advantage of using cross coverage. It's not like implicit or explicit bins. It can be used for any type of cover points. The two things are, one is to monitor simultaneous actions of the three different cover points, and the second one is to have the flexibility of exercising the wide range of variety of combinations. So for these two things, we use the cross coverage. And
Yeah, got it.
okay, fine, Devika, that's fine. No problem. And then the other thing is, so can we use the cross coverage between the different cover groups? Supriya, would you like to answer? Everyone is doing multitasking. That's why people are unable to answer. Anyone in the group? Could be Abhishek, Anil, anyone can. Kiran.
It is
Hello.
possible.
Yes, ma'am. Yes, ma'am. Possible, because for in different cover group also there are different cover points. So we can cover different scenarios using that cover points, so we can use cross
Yeah,
coverage.
you can do the cross of two different cover groups. We have discussed
Hello.
the cross can be happened only for two different cover points. It cannot happen for two different cover groups. Okay, if that is because each cover point, and you can also do can't do the cross of the cover group from cover point in one cover group cannot be crossed with the cover point in the other cover group, because this cover point cover group will be having its own sampling time. So it can, there will be a mismatch. There could be a data loss from one cover group to other cover group. If you do, you can only do the cross of two different cover points or multiple cover points, n number of cover points. You can just do the cross, but you cannot do the cross of two different cover groups. So these are some of the tricky and important questions. So make a note of it.
Because
If you haven't done so far, you just go through the session once again. You already have the recordings. There I have explained why we can't do the cross of different cover groups. We can only do the cross
ma'am, you
of
say,
cover points. Yeah, Abhishek, go ahead.
ma'am, you are saying that we can't use for different cover groups because there are a mismatch of clocking block.
Yeah, then
Sorry, clocking.
match, it cannot be done. That will be sampled at some other. We cannot do the cross of two different cover groups. Actually, we have taken that question, I guess. Okay. Can we have the cross coverage between two cover groups or two different cover points which are residing in two different cover groups? So you guys just go through this session. There we had already discussed why we don't want to do the cross, why it is not possible. So all those this interview questions, whatever session was there, just concentrate on that. If you are going for any interviews further also, just go through at least the interview questions which we have discussed, because however most of the sessions every day we do the recap of the session. So but the interview questions, these are very if we some are tricky. You will think like the cross of cover points is possible, so cover groups is also possible. So that's not the case. So just go through once. For me it is known concept, but for you guys it's a new concept, so I can understand. So you guys can go through once or twice, then you will also be familiar. And you have to try to work on number of different examples. Then you will also get familiar, because right now you guys don't have an experience in working that. So that's why you have to try to grasp that experience by trying different examples. Like that you can do it, or whatever examples are given to you in the session, and the same example you can try some different values, and that way also you can increase your knowledge, like, and you can try different combinations, why it is working or not, it's not working. If it is not working, what is the reason? So that way you have to enhance your learning, right? So guys, don't stop your practice. You keep on, the one who is trying for the placements also, I suggest that you guys have to do your practice every day. Then only the amount of the time you didn't get the experience, that can be covered when you do this practice. The one who know the concept entirely and didn't work on that for 10 to 20 days, and the one who knows the concept only a bit and is trying, he's doing every day, there makes a lot of difference between them, because they are doing it every day. So they will be learned small things by end of the 20th day. But the one who has learned everything and for 20 days he didn't even see it, he will always say like maybe this, maybe that, maybe you will be confused. You won't be that confident. So when an interviewer will look confidence in you, when you will get the confidence, when you have already experienced, for suppose you would have worked on some projects like that. So when you have worked practically, then only it will register in your mind well. So as you don't have experience, you should create your experience by working on simple examples. So these things you guys keep it in mind and go further. Definitely not today or tomorrow. You guys will get the placement only through your practice and your confidence. Okay. So then anyone can say what are illegal bins?
And from LRM, we can get questions to practice.
LRM, actually, last time also you have asked this, Abhishek. LRM is a manual where you will have the system value of all concepts. Means whether it is beginner level, medium level, advanced level, every concept will be there related to system verilog. When there is any, if you are forgetting any syntax, or there could be a situation, right? You will be forgetting the syntax. You know the concept, everything. So then you can go refer that LRM and get your concept clear. Means you can find out the syntax. You can believe on that LRM, that is the perfect syntax you will find out. Okay, and the other things, if you have some examples over there, you can practice them. Or if they have given you some example to explain you, that same example you can take it and you can do n number of changes and try to observe whether you are able to understand it or not. So now you have learned so many concepts here, like what are illegal bins, what are ignore bins, what are transition bins, what is that, the different bins we have learned, right? Transition bins, illegal bins, ignore bins, and then implicit bins.
Your voice is breaking.
Okay. Is it clear now?
Ma'am, it is clear, but like, can you refer some book,
Unable to
some
hear you, ma'am.
material from which I can do some practice on for some questions? Like you are asking some question here now, like that only.
Yeah, means these things you can try, which I have provided you in the set. Sudha, is it audible now?
Yes, ma'am, audible.
So
Yeah, now you're audible.
Yeah, so you can try the same questions first. Once you are clear with all these questions, right, then you can make small changes. So see, now you have learned so many concepts, like we have wildcard bins, we have different bins concepts you have learned, right? So all this you can try in that particular code. If I do this way, how it will work. If I do this way, how it will work. And that is how you have to learn. Nowhere you will get the entire material. You will only get some like this. I have shared more so many questions in this session, in this workshop. So you can pick those questions and you create your own question from that. You can create your own change like that. Like that you can try.
Okay, ma'am.
So first tell me, anyone, what are the ignore bins or what are illegal bins? What are the difference between the ignore bins and illegal bins? These three questions you guys answer.
If we don't want those bins to be in cover point, we
Hmm.
can use ignore bins or illegal bins.
Okay.
When we use illegal bins, we will be getting error in the output,
Correct.
and there will be no error in the ignore bins.
Okay, that will be a runtime error or compile time error, the illegal bins error which you get. It's a runtime error. Okay.
Okay.
Yeah. And then in assertions, it's clear, right? Can anyone list out so far what we have discussed in assertions? No one else is there in the session or what?
We have discussed about what is assertion, different types of assertions like immediate and concurrent assertions,
Yeah.
and built-in functions which are used in assertions.
Okay. Okay.
Yeah.
Okay. So what is the main difference between immediate and concurrent assertions? Okay.
Immediate assertions are evaluated in one single clock cycle and they are evaluated immediately.
Yeah.
Concurrent assertions are spread over the multiple clock cycles.
Correct. Thank you. So, can anyone say what is an $1 hot system function of assertion? What does it do?
$1 hot is used. It returns the value of 1 when there is only.
Hello.
Just wait, Abhishek. Yeah.
When it is like input is like 0, 0, 1, like only one bit is the 1 and remaining all are zeros.
So that one bit can be only 001 or it can be 010 also. It will
Anything.
anything.
Yeah, 010 also it will work. Or any one bit should be 1, remaining all should be zeros.
Correct, correct. Super. Yeah. So now we will discuss about, we have already discussed some questions on assertion. So now, see, I have written this assertion. We have one assertion here. So based on this same question, you can make some different changes, whatever. You can see this question and you can think like what kind of question might come, what the other person can ask me. So in this particular property, what the change that I can do. That way you have to keep on, from the same question, you can derive some 10 to 15 questions and you can work. So likewise, you have to develop first, and then you can go through. If you get any questions from anywhere, then you can start working on them. But first, before you should able to work on the questions which you have already received, and this you should be very confident in this. Whatever change they do and give it to you, you should be able to do. So first you have to strategize in such a way that whatever is known by you has to be answered by you in whatever way they have asked, and then you can go to the advanced things. So we have worked so far some 5 questions on assertions, and before that we have gone through some codes to understand the different system functions of assertions, right? So today I have taken some more questions for assertions, and then after that, if anyone have any queries related to any like verification engineer or anything, we can discuss. Okay. I to summarize what all we have gone through about the assertions is, first thing is we have gone through what are assertions, and then what are the different types of assertions, and then we have gone through like the different operators in the assertions, like we have something like repetitive operators, cycle delay operator, and then we have gone through the built-in methods like $rose, $fell, and then $stable, $passed, and then we have also gone through the built-in functions like $count once, $count $one hot one, $one hot zero, and then and then and then something else. One was missing. Dollar is unknown. So all these we have gone through, and we have gone through something like what is disable if and only if. Through this course we have gone through, and we have also gone through the different types of operators. That is, we have implication operator and overlapping. In implication, we have again 2 types. One is overlapping, and the other one is non-overlapping. So can anyone explain what is overlapping and non-overlapping? Because this is very much useful to build your assertion. So it's good if everyone know about it. That's why I'm asking you once again. What is the difference between the overlapping implication operator and non-overlapping implication operator?
Hello. Overlapping implicator is used to assert the is used to check the second condition in the same cycle of the first one when it is correct. Like if first one is correct in this clock cycle, then the second operator is also being checked in the same clock cycle.
Correct. Yeah. So second, in the sense you assume that the implication right side and left side. Okay. So the implication left side is the condition. If it is evaluated to true, the right side part will get executed. That way, if your understanding is, then it's right. If it is something other than that, you just modify.
That is the one. Yeah.
Okay. Good. So overlapping, non-overlapping means it will start from the next clock cycle. Okay. So now let us see some questions. That is, like there is a question saying that as long as the signal A is up, means basically up in the sense asserted, or in the high state, it's in 1. And the signal B should not be asserted. Write an assertion for this. So I would like anyone can present your screen and start writing something like whatever it comes in your mind, that is okay. You guys try, because so far we have developed so many assertions, right? With that knowledge and with that using system functions, you just try. That's okay if you go wrong, because unless you put your pen and paper, it will be easy for you. When you start writing, you will get so many doubts, like what is the syntax, how do I start, like that. So that's why today I didn't put the solutions, because it will be like a spoiler for us. Our mind will not think anything other than that. So I want you, any one of you, to present your screen and start writing for that. And I'll help you in between, that's fine. Sudha, will you try?
Yeah, I'm just thinking like what will be the logic?
That's okay. You just start writing, I'll help you. You can present your screen with some notepad or something. You just start writing. Start something like property and property, that is also fine. But you just start writing. I'll
Yeah,
help you, don't worry.
Actually, I connected in my mobile. Can I switch on the back cam so that I'll write in the book and I can see?
Anything is
Is
okay.
that
Anything.
okay? One second. Can you see my?
I am able to.
Actually unable to see. Like, was my back camera on or front camera on? Okay,
Now
back.
it is back camera on. I'm able to see your paper and pen. So now it's fine. You start. You can give some name to the property just to understand for what you are writing the property. So you can put a naming convention related to that. You can put like signal A underscore signal B like that, so that you will understand you are writing an assertions related to signal A and signal B. Okay.
Property is
Underscore A underscore B, or that is user defined actually. So I'm just giving
okay.
like the naming convention should be something like anyone will understand seeing the property like this property is for what. Okay, that's why. Okay. Okay, and you are writing like at the rate of posits of clock. So that is your triggering event when this property has to be evaluated or executed.
Yeah.
And then you want to write some condition when it is you want to disable this assertion at any point of time. Like for suppose you don't want to evaluate this assertion if there is no reset, then how will you write? You will write using some construct, right? Like disable if and only if, that you can mention. That's
Okay.
what we have gone through, right? Here I will show you. This is the disable underscore if and only if not of reset, like that you can write. Okay. So, now main part. Okay, that is like when the signal A is asserted, the signal B should not be asserted. Means when signal A is there, signal B should not be asserted. That condition you have to check. So how can you write like when how to find when it is asserted or not? How to find when it is de-asserted or not? So something related to those system functions you can think and you can write.
So here, like A should be high.
As long
Then,
as B should not be high. So first A should be high. At the for suppose A is high from 10 to 20 units. In that duration, in that span of time, the B should not be high. So that is the condition.
like, is it A is not equal to negation of B?
That's okay, right? Whatever it comes to your mind. Okay, you have written like a negation of A. Means for suppose A is 0, it means negation of A means 1 should not be equal to B. B is suppose you have taken like now negation of A is not equal to B. So A value is 0, we suppose, and B also has 0. In that case, when negation of A means what, it will come 1. And it should not be equal to 1. That is what you are giving, right?
Can I
Yeah.
say?
Yeah, tell Abhishek.
Ma'am, dollar rose, dollar rose A
Oh.
implication B is equal to 0.
Okay. Can you
Dollar rose.
dollar rows of A? He's telling like dollar rows of A, then the implication will happen. And then he's telling like what should
B
be
is
there?
equal to 0.
B is equal to
B is equal to 0.
yeah. Yeah, that will work. So basically, let me present my screen. See, now I will write a property like this. Okay. So this is my property name. I am writing like it is related to both signal A and signal B. And then I am writing like, for example, I want to check at the positive block. Then,
Ma'am, your screen is not visible.
oh, is it? I think I did it for only. Now is the notepad visible?
Yeah, it is visible now.
Yes, ma'am.
Like this. And then what Abhishek has told, that also will work. I think this way. See, the one good part is we can analyze this way. Means when it is, it's not a hard and fast rule that it has told like first it is given like signal A is up, then signal B should not be exited. So it shouldn't. It need not to be start with signal A only. So you can always write a negative condition to get the positive condition also. You can think in a reverse way also. So what I can write, for example, there is also one more operator called until. Okay. So using that also we can use write, and you can also write using implication operator. So there for one kind of requirement of the assertion, there could be n number of solutions. It is all up to you how you will create it. Okay. So I will tell some two approaches now, and then we can see. Okay, we can write something like dollar fell of signal B means you are checking for the condition of B when it is low. Means fell means what, high to low. When it is that condition, in that case, what is the requirement here? The signal B should not be exited when as long as signal A is high. So you can write something like how in English we use the until, the same meaning in the assertion. So you can write until the signal A is high, or you either you can use the just signal A, or you can use dollar rows of signal A. So what this will give, the signal B when it is low, until then this will not get exerted only. So likewise you can write, or you can even write like this, like dollar fell of signal A. What was the thing we had written previously? Signal B. So now dollar fell of signal A you can write, and then you can take an implication operator. Like this you can take and check for the signal A is high. So when this is condition is satisfied, then only your signal A will go high. Otherwise it will not. So then also the same requirement serves the purpose, right? The signal A should be high until when this is not as not asserted, this should be high. So that will also work. And so this way you can try working on the different conditions. So in this same question, you can try different after so many clock cycles, if it is getting asserted. Likewise, you can try different things and understand the different and try to use different properties you have learned, so that you will not forget its functionality like that. Yeah. So that tell me.
Is that signal A or signal B? Dollar fill.
Signal B.
Okay.
Okay, so this is one question. The next is the signal A is a pulse. It can only be asserted for one clock cycle and must be de-asserted in the next clock cycle. So how will you write for this? Any idea? You can write like this, right? So signal A is a pulse. So basically pulse in the sense if they are trying to say that it is from, it has to assert the peak, means it has to go to the high position. Okay. So what I can say, I can take dollar rows of signal A, which will detect me the condition, the signal A going from 0 to 1, right? So once I get that condition, again at the next passage only it will check, right? So for one clock cycle, I can use one implication operator. It has to be asserted for one clock cycle. When I use a overlapping implication operator, then I can take that hash one clock cycle after that. And then I will see that my A signal A has got de-asserted or not. If I am not using the overlapping operator, I am using non-overlapping operator, then you need not write that extra hash one clock cycle also and directly check that the signal A got de-asserted or not. So with this, you will able to figure out like the signal A is asserted only for one clock cycle or not. So you can write this. So this is for the second requirement. Actually, the signal A is pulse. It can only be asserted for one clock cycle and must be de-asserted in the next cycle. So if we are using overlapping implication operator, you have to use the one extra clock cycle delay. If it is non-overlapping, then you can omit that clock cycle, because these both say means the same. That's why. And then we'll go to the third one, that is signal A and signal B can only be asserted together for one clock cycle. In the next cycle, at least one of them must be de-asserted. So how will you write this?
A hash one
Okay.
B for the first one.
Only B.
Asserted together for one cycle.
Hello.
Sorry, ma'am, your voice was
Yeah.
not audible.
1 minute. Yeah. Go ahead, Sudha. I'm sorry.
A overlapping B. Overlap. Sorry, A non-overlapping B for the first one.
Okay. For this part.
Yeah, asserted together for one cycle.
Okay. Okay.
Together one cycle. Yeah.
Hello.
But it is like asserted together for one clock cycle, right? But if you write implication like that, signal A and implication signal B,
Okay.
in that case, when signal A is high, then only it will, but actually if you are using overlapping, the signal B can also be asserted in the same clock cycle, so it will work. But you have some other condition also, so there will be a sequence of implications if you want to do like that. So what you can do is you can create one sequence. In that sequence, you can write like signal A, implication signal B. Means in the same clock cycle, signal B also should be high, signal A also should be high. And then you can take one more sequence to solve the different thing. Okay, that is like in the next clock
Okay.
cycle, at least one of them must be deasserted, it is telling. So you can hash one clock cycle. So sequence one will be already declared. No, you can you will be giving some name for that sequence. So that sequence one, that hash one clock cycle delay, and then you can check like at least one of them must be deasserted. You can write like either signal A should be negated or signal B. You can also use a just word called or. That also says that any one of the signal should be high. Okay, that can be done. What you have told also can be done. What I can think of is I can check dollar rows of signal A and signal B both. Okay.
Ma'am, may I try?
Sorry.
Ma'am, can I say something?
Yes.
Ma'am, I want to write like that, like A and operation, B and uh, implication operator, and after that hash one and negation of A or B.
Sorry. Can you please repeat?
Ma'am, A and B,
Okay.
after that implication operator, hash
Uh,
one,
hmm.
negation of A or B.
Yes, that can also be done.
Okay.
Negation of A or negation of B, like that you have to write.
The negation of A or negation of
Oh,
B.
that will also work. What we can and the using, if we want to use with the built-in functions, then you can write like dollar rows of signal A and the signal B, means all both the signals should be asserted. And at that point, after one clock cycle, you can check like dollar stable is there, no? Means if any of the signal is if they are asserted, and if here the dollar stable is returning zero, it means it is not stable, right? It has changed from the 1 to 0 or 0 to 1. So you can write not of dollar stable of that signal A or signal B, like that also you can write. So through that, whether it either it could be when it is deasserted only, the dollar stable will return as 0. So to use the dollar stable system function, how you will, in what kind of scenarios you can use, that's why I have taken that particular this particular question. So all the solutions given by you, Sudha, Supriya, everyone, whoever has given the solution, that will work. And this is also one of the solution. You guys can add to it, okay? And then the last thing is signal A must not be asserted before the first signal B may be asserted on the same cycle as signal B. So means it is telling like signal A should not be asserted until the signal B is asserted. So signal B only first it should be asserted. It can be like when signal B is asserted, in the same clock cycle signal A can be asserted, but not before that. Then how will you write?
Negation of signal A, implication signal B.
Correct. That also works. Yes. Or you can write like the signal A, negation of not of the dollar rows of signal A until the signal B is high. So until means when the signal B is not there, then this won't have, this will be in the de-asserted condition itself. When the signal B is high, then only you will have the signal A to be rows. It should not be zero. So like that also you can write. So you can use this until keyword more oftenly when there is a situations like this, one before the other, one after the before, like that. If there are some things, right, in those cases you can always use this until keyword. So I'm just all the solutions are correct. Just to I'm telling you so that you will be familiar with the keywords. Okay, so that is one thing. Let me give one more question. For suppose my requirement is like the request is one of the signal. This has to be one, means has to be asserted basically. Eventually, I can say, means between some clock cycles. There is no specific clock cycle, any number of clock cycle. That should be followed by acknowledgement signal. Means after this happens, the acknowledgement should go high. And that should be followed by one cycle delay. And after that, the done signal should go high. Like this, you can write. If there is a requirement, how will you write? So when it is between any number of clock cycles, how will you provide the thing is the main part catch in this question. You can write like this, right? For example, first request has to be asserted. So you will write request has to be one basically. After that, I am taking an implication. And then I want to check the range of the clock cycles, right? So I don't know how many clock cycles it will take. So I will just give $1 to $. So this will be like in between any one to any number of clock cycles, it will trigger the thing. It will consider that. Okay. That request will be asserted within that clock cycle. After that, the acknowledgement will be high. That is this part of the thing. And after that, one clock cycle, the done signal should be high. So you will write like this. Okay. Or if you feel this is tough for you, you can split this into part of the sequences. Request has to be high, this, and then you can put this into some other sequence. For this, it is not necessary. It is simpler one only. There can be n number of events like this, something for suppose. Then you can create different sequences, and you can use that particular sequence and write some clock cycle delay operation in between those sequences, and you can create one property. So that way also you can work. Okay, so this is all about the assertions. So you guys can ask me if you have any questions.
Like this is out of the question. Like, may I know the difference between if they ask us, are you worked on IOC or SOC, IP level or SOC?
Okay.
So do we have anything that will be related to assertions?
No, it won't be. See, in our project, we can write assertions, whether it could be IP level or soft level, any level, you can write some assertions if it is required. For example, there is some subsystem level requirement. There is a feature called low power feature. So low power feature means when there are that low power, when our particular system is going to low power, some signals that low power request should go high and our clock should stop. Like that, there are some features for suppose. So you can implement that particular feature using assertion. You can write like when this is the low power request is high, at that point that clock should cancel it to zero. Likewise, you can write some set of assertions. So based on the requirement, what kind of project plan is there based on that. So anywhere you can write assertions. So it is not respect to any IP level or SOC level. So Sudha, do you have already the experience in ASIC verification or you are studying? What is the status?
No, I'm not experienced.
Okay,
Fresher one.
pressure. So you have done your MTech and now you are trying for the jobs or how is it?
No, I've done my BTech, but I was doing job in non-IT industry. Then I'm trying to shift my path to this,
To VLSI.
towards real estate. Yeah.
Great. Good. Okay, that's how it is. Yeah. Anyone else? Anyone have any questions? Okay, in that case, we'll close the session. So,
One more thing, like what are test cases? Like if they ask us in interview.
mhm. So did you work on any of the test case development before?
No, I don't have any idea about that. What are test cases?
Okay, so basically, see, for example, now we discuss about so many things like how to how to improve the coverage, all this. So for that, we have something like we have a design. So we need to verify the design, right? So to verify the design, we will write a test case. So you have an idea of Verilog, right? In Verilog, how we write a design
Yeah.
and write a test bench, right? So in the same way,
Yes.
in Verilog, we write a design. In the test bench, we give the stimulus for that. So means you will give like, for example, you have written a design regarding request, then acknowledgement, then done. All this you have written. So in the test bench, you will give a stimulus, no? Like request is high for some clock cycles, and then request is low for some clock cycles. So you are trying to put some different inputs and check your design is working properly or not. Like how I will say is like for example, a truth table for an AND gate. So you will design there will be a design for an AND gate. From the test bench, you will give two inputs. For suppose this is a two input NAND gate, A and B. So two inputs means what? So total four combinations you will have. So all these four combination from where will you give? You will give from the test bench. So in the test bench, you will give
Test bench.
less. Like there are two inputs for this AND gate. So this AND gate, you will give A value as 0, B value as 1 once, and you will try to observe the output because you had already written the output like Y is equal to A and B or something, right? So based on that, your design will work. So whether your design is working properly or not, how will you find out is when you write all these four tests. These are nothing but four test cases where you will give A value as 0,
Okay.
0, 0, 1, 1, 0, 1, 1. So if all these four test cases are passing and giving you proper answer, it means that your design is verified like this. Like this you do, right? So in the UVM also for any of the project, this is a simpler one. Likewise, you will have very complex designs. For all those complex design, you will understand the specification and based on that, you will create a test bench. In that, you will have the architecture like generator, driver, all this you will have. So based on those, we will have something called test. Then we'll have sequences. In the sequences, you will give this kind of whatever based on like how I explained you for the AND gate. In the same way, based on the design, you will create one specification and the requirement, and based on that, you will give the test case over there. And the test case will instantiate the sequence, and that in the test we will start the sequence on the sequencer. So to understand all this, you should know like what is system Verilog, what is UVM, all these things. If you are aware of, if you work on any one of the simpler project, then you will understand what are test cases like that. But to understand at this level, as you don't have any knowledge on those things, what exactly the test case is for, purpose is for, that's what I explained you. But if you want to appear for interviews in the VLSI, you should have those knowledge like system Verilog, UVM, everything you should be aware of. And after having a good knowledge of system Verilog and UVM, you should work on any one of the simpler projects also fine. Then you will get the total overview of like what it is, how it will work.
Yeah, okay.
Okay, yes.
Thank you.
Yeah. So Sudha, you can ping me if you want any more things about the system Verilog and UVM. I can guide you. Like if
Yeah, sure, ma'am.
Yeah, you can ping me by taking the number from the group. Are you there in the Assertion base?
Yeah. No, I'm in different one.
Okay, fine. Yeah.
Hello.
I'll ping you. I have your number.
Yeah. So you have my number in that case?
Like, was it the same number in the PDF? No, on the PPT which you were presenting.
No, that's not my number. Okay, you be in the session. I will tell you my number. You can ping me. Okay.
Okay, sure.
Yeah. Then Abhishek, you were asking.
Hello.
Yes, ma'am. Ma'am, I want to ask, like, last year I completed my internship in one company, and after that I passed out MTech. But after that I am searching for job. I am at my home, so I want to know that, like, if I